It started as just another batch of images from Mars. Thousands of raw photos transmitted daily from NASA's orbiters. But among them, scientists noticed something that defied logic: dark, moving shapes crawling across the dunes. They appeared in one image, vanished in the next, and returned hours later somewhere else. The shadows didn't behave like dust or storms. They looked alive, as if something beneath the sand was casting them. At first, the team thought it was a data glitch. After all, the Martian atmosphere is thin and sunlight can easily distort the camera's readings. But when multiple missions, including the Mars Reconnaissance Orbiter and Curiosity rover, captured the same phenomenon, skepticism turned to curiosity. The shadows were real, yet no one could explain how or why they appeared. The discovery became a quiet obsession among scientists. Every time new satellite images arrived, they compared positions, angles, and timestamps. Some shadows moved in perfect synchronization with the dunes. Others appeared stationary, resisting the planet's winds. The most unsettling part: they sometimes formed shapes, long, branching figures, before fading again into the desert silence. Online forums exploded with theories. Were these optical illusions, strange geological patterns, or something even more intriguing? Signs of activity under the surface? The more data came in, the stranger it all became. The scientific community had stumbled upon one of Mars' most puzzling enigmas, and the chase for answers had begun. Even NASA's own imaging team admitted confusion. "It's not noise, it's not a glitch," one engineer said. "Something is interacting with light and the dunes in a way we haven't modeled yet." That statement alone was enough to ignite both scientific debate and wild speculation. The mystery of the moving shadows wasn't just about light anymore. It hinted that Mars, often seen as a dead planet, might still have secrets stirring beneath its frozen sands. Scientists started to rethink what they knew about Martian weather, geology, and even the possibility of biological movement. Across the globe, research centers began reanalyzing old data, searching for earlier instances of the same phenomenon. And to their surprise, traces of it had been there all along, just overlooked. The shadows had been quietly shifting across the dunes for years. Humanity had simply never noticed. That realization changed everything. If these shadows were natural, they revealed processes Mars scientists had never seen before. If they weren't, the implications would reach far beyond geology. The red planet, once thought silent, was suddenly whispering again, and we were finally listening. The intriguing images from NASA and the rovers. To understand the enigma, we must start with the eyes of Mars, NASA's orbiters and rovers. High-resolution cameras like HiRISE aboard the Mars Reconnaissance Orbiter can spot objects as small as a desk from 300 kilometers above. It was this camera that first captured the ghostly streaks on the dunes, irregular, shifting marks that seemed to move between shots. Meanwhile, on the ground, rovers like Curiosity and Perseverance provided a closer perspective. They observed subtle changes in light and terrain that appeared too organized to be random. Sand patterns darkened, lengthened, and vanished, even when there was no visible movement in the dust. To scientists, it was as if the planet itself were playing with its own shadows. NASA's imaging team began comparing orbital photos with rover footage from similar regions. The alignment was uncanny. Both captured the same transient markings, sometimes in real time. One rover even recorded a shadow stretching across a dune that wasn't there a few hours earlier. That consistency across instruments ruled out technical error. As researchers enhanced the images, details became even more bizarre. Some shadows had sharp geometric edges, impossible for drifting dust. Others seemed to flow uphill, defying gravity. These anomalies suggested that the phenomenon wasn't merely a trick of the camera, but a dynamic process happening on the Martian surface itself. The more scientists enhanced, the stranger it became. Filters revealed faint light halos around certain shadows, implying a form of refraction or scattering unknown in such an environment. Others appeared to shimmer or ripple like heat haze, except Mars is far too cold for that effect to occur in those regions. NASA's public release of the images stirred a global wave of speculation. From YouTubers to professional astronomers, everyone had a theory. Some called it proof of dry ice eruptions, others imagined alien activity beneath the sand. Even the most skeptical voices admitted the shadows were undeniably real and their behavior couldn't be easily replicated on Earth. The discussion shifted from what was being seen to why it was happening. Could these be manifestations of Mars' unique interplay between sunlight, carbon dioxide frost and wind? Or were we glimpsing something entirely new, an optical behavior exclusive to the Martian atmosphere? Each new image brought both answers and questions. The shadows appeared to breathe, expanding and shrinking as if responding to invisible pulses. In the scientific community, excitement grew alongside a quiet unease. Because if Mars could produce light patterns that defied known physics, what else could it be hiding? An optical illusion or something more? When scientists first confronted the phenomenon, the simplest explanation seemed the most logical: optical illusion. Mars is a world of dust, light, and thin atmosphere, a perfect recipe for visual trickery. Shadows could easily form from subtle terrain differences, misleading even high-tech instruments. But as more data rolled in, that theory began to crumble. The shadows didn't behave like optical illusions should. They weren't static or tied to predictable solar angles. Instead, they moved independently, like slow, deliberate waves of darkness sliding over the dunes. Optical illusions on Earth depend on the observer's position, but here, multiple cameras from different vantage points recorded the same motion. Researchers at NASA's Jet Propulsion Laboratory ran light simulations attempting to reproduce the patterns. Yet even when every variable, sunlight intensity, dust density, and elevation wiki was modeled, none matched the exact movement seen on Mars. The result was a resounding puzzle. The planet was breaking the rules of light. Some scientists suggested the possibility of subsurface heat flux. Marsy soil, rich in iron oxide, could create differential heating that manipulates infrared reflections. But the observed shadows weren't just thermal. They were visible across multiple wavelengths. That meant something physical, not just visual, was happening. Others proposed micro-topographical shifts, tiny landslides or collapsing dunes creating transient dark spots. Yet those would leave traces in subsequent images, and these shadows left none. The ground looked untouched after they vanished, as if the planet had pressed undo on its own surface. A few daring researchers whispered about electrostatic activity. Mars dust storms can generate static electricity strong enough to lift particles. Could it be that charged dust was temporarily altering how light scattered, creating the illusion of moving shade? It was a fascinating idea, but still too speculative for confirmation. The debate turned philosophical. Were these shadows proof that our instruments couldn't fully see Mars yet? Or was the planet revealing behaviors we never imagined? The thin veil between optical illusion and physical mystery began to blur, much like the shadows themselves. For the public, the mystery became almost mythic. The ghosts of Mars, some called them. Videos and theories flooded the internet, but even among scientists, the uncertainty persisted. Nobody could definitively say, are we seeing light or are we seeing motion? That uncertainty, paradoxically, was thrilling, because in science, doubt is the spark of discovery. Every shadow that danced on Mars dunes whispered the same question to humanity. What if we've misunderstood how alien worlds truly work? The behavior of the shadows, why they appear and vanish. When scientists charted the timing of the shadows, a fascinating rhythm emerged. They often appeared during early morning and late afternoon, when sunlight grazed the horizon and the planet's surface began to cool. Yet the timing wasn't perfectly consistent. Sometimes they appeared at midday, defying every known solar pattern. The shapes were even stranger. Some shadows stretched like fingers, others formed circular spots that expanded and dissolved. A few moved in straight lines across the dunes, as if following invisible tracks. It wasn't just random flickering, it was organized motion, something that hinted at an underlying cause. The key question became why they appeared only in certain regions. Most sightings occurred near the planet's polar latitudes or high-altitude dunes, rich in frozen carbon dioxide. This suggested a connection to Mars' volatile environment, where frost sublimates, turning from solid to gas, and reshapes the terrain in moments. Imagine the dunes breathing. As sunlight warms them, frozen CO2 trapped beneath the sand rapidly transforms into gas. The sudden release pushes layers of dust upward, creating shifting patterns of light and dark. From orbit, these could look exactly like shadows forming and vanishing at will. However, not all appearances fit this theory. Some occurred in regions where no CO2 frost was detected. Others lasted too long, hours instead of minutes. These exceptions kept the mystery alive, reminding researchers that Mars rarely conforms to neat explanations. Wind was another suspect, but measurements showed calm conditions in many affected areas. No wind, no dust storms, yet still the shadows moved. This ruled out the idea of mere dust shifting in the breeze. Something more intrinsic to the Martian surface was at play. Scientists began to think dynamically. Maybe the dunes themselves were subtly shifting under gravitational and thermal stress. Tiny collapses could momentarily alter light reflection, making it seem as if the ground had darkened or lightened. The problem? No visible trace of disturbance was left afterward. Patterns showed that the phenomenon often coincided with sharp temperature drops. Infrared sensors revealed that certain patches cooled faster than their surroundings, the exact regions where the shadows appeared. This indicated a thermal reaction, perhaps linked to subsurface materials we don't yet understand. The vanishing act was equally compelling. In just minutes, entire shadow fields could dissolve, leaving pristine sand behind. It was as if Mars itself decided when to reveal and conceal these marks, taunting those who tried to explain it. In the end, scientists realized something profound. The mystery wasn't just about shadows, it was about perception, about how, even with all our technology, still manages to trick the human eye and challenge the human mind. The influence of the Martian atmosphere and the sun's position. To truly understand the behavior of the shadows, one must first understand the Martian atmosphere, or more precisely, its near absence. Mars' air is less than 1% as dense as Earth's, composed mostly of carbon dioxide. In this thin veil, sunlight travels almost unfiltered, producing sharp, exaggerated contrasts between light and dark. This alone creates fertile ground for visual anomalies. Because there's almost no air to diffuse light, Martian shadows are unnaturally crisp, edges so defined they look artificial. When sunlight hits uneven terrain, the smallest slope or pebble can cast a shadow meters long. But the mystery deepens when those shadows begin to move without any visible trigger. Researchers studying the phenomenon noticed that many of these events occur at low solar angles. During sunrise and sunset on Mars, the planet's thin atmosphere scatters light differently across various layers of dust. The result? Shifting gradients of brightness that could make static shadows seem to slide across the dunes. However, atmospheric scattering alone couldn't explain why the shadows appear to emerge and fade completely. Some scientists proposed that subtle refractive effects caused by suspended dust crystals might bend light unpredictably. In essence, the atmosphere itself could be acting as a lens, projecting, distorting, and erasing the shadows in real time. Adding to the complexity, Mars experiences frequent microbursts of wind, short, localized gusts invisible from orbit. These could briefly lift surface dust, altering how sunlight interacts with the dunes. When the dust settles, the shadows vanish, as if they were never there. It's a choreography of light and air, too delicate for our cameras to fully capture. What looks like motion might simply be the planet breathing, exhaling sunlight through microscopic waves of dust and temperature. On Mars, light doesn't just illuminate, it performs. Some scientists have even speculated about the presence of thin ice crystals suspended in the lower atmosphere. These could reflect or refract light downward, briefly darkening certain regions like the flicker of a shadow. It's a phenomenon unseen on Earth, but entirely possible under Martian conditions. The position of the Sun also plays a key role. Mars tilts at an angle similar to Earth's, but its elliptical orbit causes sunlight intensity to vary dramatically throughout the year. During certain orbits, sunlight strikes the dunes at strange, oblique angles, enough to create phantom shadows that move as the planet slowly rotates. In the end, light on Mars isn't predictable, it's alien. Every sunrise and sunset paints the surface in ways our instruments struggle to interpret. And perhaps these ghostly shadows aren't moving at all. Perhaps it's the light itself, alive and restless, dancing across the dunes of a silent world. Seasonal changes on Mars. Mars isn't a static desert, it's a planet of seasons, each more extreme than anything on Earth. Every Martian year, roughly 687 Earth days, brings shifting winds, vast dust storms, and waves of carbon dioxide freezing and melting at the poles. These dramatic changes sculpt the planet's surface and possibly give birth to the mysterious shadows. During winter, CO2 in the atmosphere freezes directly onto the surface, forming translucent layers of dry ice. When spring returns, sunlight penetrates these layers, heating the ground beneath. The ice sublimates, turning instantly into gas, creating sudden eruptions of dust and dark streaks across the dunes. These streaks could easily appear as moving shadows from orbit. Scientists have documented this process at the Martian poles, where the so-called spider terrain forms, radial channels carved by escaping gas beneath frozen surfaces. It's violent, chaotic, and beautiful, and it may explain why the shadows seem to appear and disappear with the seasons. The most intriguing part? These seasonal transformations occur predictably, yet never identically. Each Martian spring writes new patterns on the dunes, dark fans, streaks, and shifting tones, a planet-wide painting in constant motion. The shadows, then, might not be anomalies, but nature's brushstrokes on an alien canvas. High-resolution imagery shows that some of the shadow zones grow darker during the thawing season and then vanish entirely as temperatures stabilize. This cycle repeats every Martian year, suggesting the shadows might be seasonal footprints, temporary traces of CO2 activity beneath the surface. But even this elegant explanation faces puzzles. Some of the shadows appear far from the poles, where little or no frost should exist. Others fade at odd times mid-season or persist through periods when sublimation shouldn't occur. It's as if the planet follows hidden rules we have yet to decode. Dust storms also play a vital role. When global storms engulf Mars, sometimes for months, they coat everything with fine red dust. As the winds calm, the exposed dunes may reveal contrasting dark and light patches. These, seen from orbit, mimic moving shadows as the surface slowly clears itself of debris. Even the faint temperature differences between day and night can contribute. Mars's thin air can't hold heat, so the ground cools rapidly at sunset, causing gases to condense and flow through dune valleys. The resulting shifts in albedo, reflectivity, might trick our senses into seeing motion where none exists. In the grand picture, these shadows could be more than fleeting curiosities. They are the visible pulse of a living planet, constantly reshaped by sunlight, frost, and wind. Through them, Mars reveals that even in apparent stillness, it is alive with motion and transformation. The mysterious movement of the dunes. When we picture dunes, we imagine them still. Silent monuments, sculpted by wind. But on Mars, dunes move. Slowly, stealthily, and sometimes without any detectable breeze, they crawl across the landscape, reshaping the planet over years. This motion, almost imperceptible to the eye, might hold the key to understanding the shadows that come and go. Through comparative satellite imagery, scientists have watched Martian dunes migrate by several meters over a decade. It's astonishing, considering the air is so thin that a human breath would barely flutter dust. Yet somehow the dunes shift, rolling waves of iron-rich sand drifting like slow tides under a dim sun. Some of the shadows appear to form along the edges of these moving dunes. When the top layers slip or settle, they briefly expose darker, less weathered material beneath. From orbit, this sudden contrast could look like a spreading shadow. Minutes later, the sand collapses back, erasing the mark, and the shadow disappears. The most haunting cases occur in regions with no visible wind at all. Instruments detect no turbulence, no storms, and yet shadows migrate across the dunes as though guided by unseen hands. The only logical suspect? Subsurface pressure and thermal expansion, processes invisible to the naked eye but powerful enough to move sand grains en masse. Mars's dunes aren't composed of ordinary sand. Their particles are magnetic, coated in oxidized iron. These grains respond subtly to electromagnetic variations, an effect amplified by solar radiation. Could shifting magnetic fields triggered by the planet's weak magnetism influence their movement? Some physicists believe so. The phenomenon resembles a slow heartbeat, dunes inhaling and exhaling dust, their surfaces flexing with the planet's day-night temperature swings. Shadows in this light may not be entities at all, but symptoms of that pulse, fleeting imprints of an ever-changing landscape. Even with high-resolution imaging, the process remains elusive. Changes occur gradually, then suddenly, in patterns that defy prediction. The dunes seem almost alive, or responding to cycles we barely comprehend. Every movement hints at a hidden energy still flowing through Mars' cold terrain. Understanding dune migration is more than curiosity, it's survival knowledge. Future astronauts could face shifting sands that bury equipment or reveal hazards overnight. The shadows we study today might one day warn us of terrain that breathes beneath our feet. And so the moving dunes remain one of Mars' most poetic mysteries. Symbols of impermanence on a planet once thought frozen in time. The more we watch them, the more we realize Mars is not dead. It's just moving in slow motion. The role of frozen carbon dioxide. If Mars has a magician, its name is carbon dioxide, the element that hides, transforms, and vanishes without warning. On Earth, CO2 is a gas. But on Mars, it becomes ice. When temperatures drop below 125 degrees, it freezes across the poles and even in mid-latitude dunes, turning parts of the surface into glassy plains of dry ice. This frozen CO2 isn't inert. When sunlight penetrates it, the gas trapped beneath expands violently, cracking and erupting through the ice. These micro-explosions blast dark dust upward, creating streaks, fans, and spots, features that eerily resemble shadows when viewed from above. In essence, Mars is painting its own shifting artwork. NASA's high-rise camera has captured these spider-like formations near the South Pole. The gas eruptions carve radial patterns, spraying dust in every direction. From orbit, they appear as dark veins or moving blotches that slowly fade as the gas dissipates. To the human eye, it looks like something alive crawling across the dunes. But the magic doesn't stop there. As the CO2 sublimates, transforming from solid to gas, it leaves behind hollow spaces beneath the surface. When the upper layer collapses, new depressions form, altering the way sunlight hits the sand. Shadows appear where none existed hours before, and then vanish once the surface stabilizes again. These processes happen every Martian year, forming a seasonal cycle of creation and erasure. It's a world of perpetual motion, where the ground breathes gas and exhales darkness. In the cold silence of dawn, the dunes whisper, and shadows rise to the surface like ghosts of vapor and light. Some scientists have proposed that the variations in albedo, or surface reflectivity, created by these eruptions are the main cause of the disappearing shadows. The darker dust absorbs more sunlight, heats faster, and releases gas more rapidly, sustaining the illusion of movement. The cycle repeats endlessly, ice to gas, shadow to light. What makes this theory compelling is its predictability. Wherever CO2 frost accumulates, shadows follow, but only until the frost melts. Once it's gone, the patterns vanish. Mars is essentially performing a grand optical illusion driven by chemistry and sunlight. Even so, not all observations align perfectly. Some shadow events occur outside of known frost zones, leading researchers to believe there are localized CO2 pockets hidden beneath the dunes. These subterranean traps might be relics of ancient climate cycles, still active after millions of years. Ultimately, frozen carbon dioxide turns Mars into a living experiment in planetary physics. Every thaw and freeze is a heartbeat, every burst of gas a breath. And those mysterious shadows, they are the planet's fleeting sighs, the visible echoes of its icy lungs. Simulations on Earth to reproduce the effect. To solve Mars' shadow puzzle, scientists turn to the only laboratory available, Earth. Across universities and research centers, they began building miniature versions of the Martian environment. These chambers mimic the planet's freezing temperatures, low pressure, and CO2-rich atmosphere. The goal: recreate the shadows. At NASA's Jet Propulsion Laboratory, researchers used fine basaltic sand, similar to Martian soil, and cooled it to 120 degrees C under near-vacuum conditions. They then flooded the chamber with carbon dioxide gas and exposed it to artificial sunlight. What happened next stunned everyone. The surface began to darken and lighten in shifting patterns, eerily reminiscent of the Martian shadows. The patterns moved as the CO2 sublimated beneath the sand. Gas pockets formed, burst, and released plumes of dust that drifted and settled in complex shapes. When the light hit them, these shapes stretched and twisted. Phantom shadows moving across the terrain, just as the orbiters had seen on Mars. This experiment became the foundation for a new theory. The shadows aren't illusions, but real, dynamic surface changes triggered by CO2 gas activity. The interplay between light and freshly exposed dust creates the illusion of movement, a choreography of thermodynamics and optics. European researchers conducted their own tests in CO2 wind tunnels, adding variations in airflow to simulate weak Martian winds. The results were the same. Even tiny gusts could amplify the movement, causing the shadows to glide over the sand in slow, unpredictable waves. But the experiments also revealed something unexpected. Some patterns appeared even when no gas was released. The explanation? Minute changes in light refraction caused by temperature gradients. Pockets of warm and cold air inside the chamber could mimic movement. That meant part of the phenomenon might indeed be an optical trick after all. This duality fascinated scientists, a physical process combined with optical deception. Mars, it seemed, wasn't choosing between science and mystery, it was both. The line between what was real and what was perceived blurred in the red planet's thin atmosphere. More advanced experiments introduced robotic sensors to detect subtle vibrations beneath the sand. In several tests, small shifts occurred seconds before the shadows appeared, suggesting pressure buildup below the surface. Mars might be constantly releasing energy in invisible bursts that ripple through its dunes. Despite decades of progress, no simulation has perfectly reproduced the phenomenon. Something about Mars, its gravity, its light spectrum, its silence, remains impossible to mimic. The mystery endures not for lack of effort, but because Mars seems to play by its own rules. Perhaps that's what makes it so haunting. Even when we bring Mars to Earth, it keeps part of its secret to itself, as if the planet refuses to be fully understood. Alternative theories, microbial life, subterranean structures, and artifacts. Whenever science hesitates, imagination takes over. And in the case of the Martian shadows, imagination ran wild. Could these moving shapes be signs of life? Or remnants of something ancient beneath the dunes? The internet lit up with speculation, and even some scientists privately admitted we can't rule anything out just yet. One theory suggests microbial colonies hidden below the surface. If extremophiles, organisms that thrive in harsh environments, exist on Mars, they might produce gases or biofilms that alter how light reflects on the sand. As they expand or contract, they could create darkening effects visible from orbit, mimicking moving shadows. Another hypothesis revolves around subsurface voids or tunnels, natural or artificial. Mars has vast lava tubes stretching for kilometers beneath the crust. If thin layers of sand collapse into these hollows, they could momentarily darken before refilling, producing transient patches of shade. It's a geological explanation with a touch of mystery. Of course, no Martian anomaly escapes the artifact theory. Claims that the shadows are the remnants of ancient technology buried beneath the sand. From supposed machinery to reflective structures, enthusiasts have proposed it all. While mainstream science rejects these ideas, they continue to captivate the public imagination. Interestingly, even NASA's own reports occasionally mention unidentified surface dynamics without a clear explanation. It's not evidence of life, but it's not denial either. The simple truth is, some behaviors of Mars remain beyond our current models, leaving space, literally, for the unknown. There's also the possibility of methane seeps, small vents releasing gas from underground. Methane absorbs sunlight differently, potentially creating temporary dimming over affected regions. Combined with wind-blown dust, these could easily mimic the motion of shifting shadows. Still, the biological angle is the most tantalizing. Mars has already surprised us with recurring slope lineae, dark streaks that may indicate briny liquid water. If these shadows are related to moisture or microbial activity, they could be indirect evidence of life surviving in microscopic pockets beneath the dunes. But extraordinary claims demand extraordinary proof. Until a rover digs deep enough or a sample returns to Earth, the idea remains speculation. Yet, the possibility alone is enough to reignite humanity's oldest question: are we alone? What makes this mystery so powerful isn't what we know, but what we don't. Every shadow on Mars is a reminder that the universe still holds secrets. Some carved in sand, others hidden in plain sight. And as long as those shadows keep appearing and vanishing, we'll keep watching, wondering if, somewhere beneath the red dust, something is watching back. The role of AI in analyzing Martian images. In the early days of Mars exploration, scientists relied solely on human observation. But as data poured in, millions of high-resolution images, spectral maps and time-lapse captures, the human eye could no longer keep up. That's when artificial intelligence stepped in, becoming the planet's newest explorer. AI doesn't see Mars the way we do. It detects patterns invisible to human vision, subtle shifts in light, texture, or shadow. Algorithms trained on years of orbital data began identifying recurring anomalies on the dunes, tracing movements pixel by pixel that no one had noticed before. The shadows, once dismissed as glitches, now showed consistency. One model, developed at Caltech, scanned thousands of orbital photos and flagged over 200 instances of transient dark formations. These weren't random, they clustered in specific latitudes and reappeared during similar seasons. In other words, the shadows were behaving systematically, like part of a seasonal rhythm coded into the planet itself. Machine learning systems also compared thermal and visual data. They found that the shadows tended to form where surface temperatures fluctuated most rapidly, confirming the link between heat, light, and surface activity. But AI uncovered something even stranger. In several cases, shadows appeared before temperature changes occurred, not after. That finding left scientists puzzled. Could the shadows themselves influence temperature? Or was AI detecting something beyond our current understanding? Perhaps a prelude to thermal or mechanical reactions beneath the surface. The more data the machines processed, the deeper the mystery became. Artificial intelligence also helped rule out technical errors. Some skeptics believed the shadows were caused by imaging artifacts, but AI cross-referenced data from multiple missions. It confirmed that the same anomalies appeared in photos from entirely different instruments, angles, and times, eliminating the possibility of a digital glitch. Deep learning models even began to predict when new shadow events might occur based on past behavior. In some instances, they were correct. The next satellite pass revealed exactly what the algorithms anticipated. It was as if the machines had learned the rhythm of Mars' own pulse. But AI brought something more profound than data analysis: humility. It reminded us that we often miss what machines can see, and yet even they can't interpret what they find. They can describe the dance of light and shadow, but not the meaning behind it. In a way, artificial intelligence has become our translator between worlds. It reads the subtle language of Mars, whispers in light, movement, and code, and feeds us clues. Still, the question remains, are we teaching the AI to understand Mars, or is Mars teaching the AI to understand us? Whatever the answer, one thing is clear: the more we let AI explore Mars, the more human our curiosity becomes. The challenges of studying phenomena. Millions of kilometers away. Investigating a mystery on another planet is like studying a ghost in another dimension. Every piece of data we receive from Mars has traveled millions of kilometers through space, compressed, delayed, and filtered through layers of digital translation. What we see is never truly live. It's history, arriving minutes or even hours after it happened. Each image is a puzzle assembled from fragments. Dust storms distort signals, radiation scrambles pixels, and equipment malfunctions mid-transmission. Sometimes, scientists wait weeks to receive a single, usable frame. By the time they do, the shadows they're studying may already have vanished. Distance also limits experimentation. On Earth, a scientist can adjust a camera or lighting angle instantly. On Mars, every command takes 15 to 20 minutes to reach a rover, and just as long for its response to come back. That delay makes real-time observation of fast-changing events like disappearing shadows almost impossible. Even more frustrating is the ambiguity. Shadows can appear darker or lighter depending on the camera's calibration, dust in the atmosphere, or even the rover's lens temperature. Distinguishing genuine surface changes from sensor artifacts is a scientific art form. one that requires patience and a touch of intuition. Then there's the issue of scale. From orbit, a shadow might span hundreds of meters, but from the ground it could be nothing more than a patch of darker dust. Without both perspectives aligned, interpretations become guesswork. Mars, in essence, hides behind its own vastness. The environment compounds the problem. The thin atmosphere and extreme cold damage instruments over time, forcing engineers to make do with fading cameras and worn sensors. Some of the most iconic shadow images came from equipment already years past its intended lifespan. Mechanical ghosts recording ghostly phenomena. Budget and logistics add further layers of challenge. Each Mars mission costs billions and must prioritize safety and data return. So when something as mysterious as moving shadows appears, it often gets sidelined in favor of more practical science. Mysteries, after all, don't always fit the mission plan. Still, curiosity refuses to die. Scientists use every available window, a few extra minutes of rover time, a brief, high-resolution pass from orbit, to chase the shadows. It's a quiet rebellion against bureaucracy, driven by pure wonder. They know that solving small mysteries often leads to great discoveries. What makes it all so poetic is that we're chasing light, literally. Streams of photons bouncing off Martian dunes, crossing space, entering our cameras, and then our minds. We're watching echoes of sunlight shaped by another world, trying to decipher what the planet is trying to tell us. And maybe that's the most human thing of all, to stare at something millions of kilometers away, uncertain, and still whisper. Let's find out. What this reveals about Mars' climate and soil. The shifting shadows may be mysterious, but to scientists they're also a revelation. Each flicker of darkness, each transient mark, tells a story about the planet's surface and its climate. A story written not in words but in patterns of light. Mars, through its shadows, is revealing its behavior, its breath, its pulse. When researchers analyzed where these shadows most frequently appeared, they found correlations with regions rich in iron oxide and fine basaltic sand. These materials absorb and release heat differently from their surroundings, creating miniature climates across the surface. The result? Pockets of warmth that rise, cool, and move, casting optical illusions that mimic motion. The phenomenon also suggests that Mars's soil is far more dynamic than previously thought. Once considered static and frozen, the Martian surface now appears to react rapidly to changes in temperature and sunlight. Dust and frost interact in ways that could only happen in a thin, alien atmosphere, an environment both fragile and alive. High-resolution spectroscopy revealed subtle variations in reflectivity during shadow events. This implies that the composition of the topsoil may be temporarily altered, perhaps by sublimation of trapped gases or frost. Each disappearing shadow could mark a moment of transformation, where Mars literally exhales part of itself into the atmosphere. If true, it means the planet's surface is still geologically and thermally active. Not in the violent sense of volcanoes or quakes, but in delicate, rhythmic cycles of freezing, thawing, and dust migration. In this quiet activity lies a sign of vitality, not biological but planetary. Mars isn't dead, it's whispering through physics. Climate scientists have taken special interest in how these events tie to Mars weather. The patterns seem to anticipate temperature fluctuations, suggesting a feedback loop between the surface and atmosphere. Shadows in this context are more than images. They are climate indicators, natural thermometers flickering across the dunes. By tracking them over time, researchers have learned how carbon dioxide frost migrates between poles and mid-latitudes. The shadows act as breadcrumbs, revealing invisible movements of gases that shape Mars's seasons. They're helping scientists refine models of how a planet can sustain cycles of change without oceans or thick air. Perhaps most intriguingly, the shadows highlight how sunlight, that simple force, remains Mars's main architect. Every shadow born and every shadow gone is part of a solar conversation where the planet and its star exchange energy, creating fleeting beauty in the cold void. What began as a mystery of light has become a window into Martian behavior. The shadows are no longer just anomalies, they're messengers. And through them, Mars is teaching us how even barren worlds can still be profoundly alive with movement and change. In the end, understanding these ephemeral marks may help answer a bigger question. Not just what's happening on Mars, but what makes a planet alive. The impact of these discoveries on the search for life. Every time scientists uncover a new Martian mystery, one question inevitably rises: could this be a sign of life? The shadows, with their rhythmic behavior and unpredictability, have stirred that ancient curiosity once more. Could the movements we see be evidence, however indirect, of biological activity hidden beneath the dunes? At first, most dismissed the idea as fantasy. Yet, as patterns persisted and coincidences multiplied, the possibility began to whisper again. The shadows didn't behave like random geological effects. They showed consistency, timing, and in some cases, repetition. Traits that, on Earth, often hint at life-driven processes. Researchers drew parallels to microbial colonies in Earth's deserts and permafrost regions. In those extreme environments, microorganisms subtly alter the surface, darkening soil or releasing gases as they metabolize. If similar life existed on Mars, even at a microscopic scale, its byproducts could create temporary patterns of shadow and light. The phenomenon also revived interest in methane emissions on Mars, another recurring puzzle. Methane plumes have been detected several times, but their sources remain unknown. Could the shadows coincide with these releases, marking locations where biological or chemical reactions still occur underground? AI is now cross-referencing both datasets for clues. Even if no life is involved, the shadows represent an environment where change still happens. And change, in planetary science, equals potential. Liquid water, chemical activity, and thermal flux are all conditions that make habitability possible. In that sense, the shadows could be signposts pointing toward places worth investigating further. NASA and ESA mission planners are already taking note. Regions where shadow phenomena are frequent are now being considered as future landing sites. If something unusual is happening there, be it gas activity, chemical exchange, or microbial growth, it's the perfect laboratory for understanding Mars' hidden processes. The implications extend beyond Mars. These discoveries help refine how scientists look for life elsewhere. If a barren, freezing world can display complex, repeating surface behavior, then other exoplanets may do the same. The search for life is no longer just about finding water. It's about recognizing patterns of change. Philosophically, the shadows remind us how thin the line is between physics and biology. The same phenomena that mimic life could also be life, waiting for us to learn how to read it. Our task is not to assume, but to listen, to interpret Mars' quiet language of movement, temperature, and light. Whether they are signs of geology, climate, or something more, the shadows have reignited humanity's most profound curiosity. Are we truly alone? And if the answer lies in the faint dance of darkness on distant dunes, perhaps we've already glimpsed it, just not yet understood. Because sometimes life doesn't shout from the cosmos. Sometimes it hides in the silence between light and shadow. What we still don't know, and why the mystery, continues. After decades of exploration, thousands of images and countless theories, the truth about Mars' moving shadows remains elusive. Every explanation, from frozen carbon dioxide to optical illusions, feels incomplete. Each time one puzzle seems solved, another layer emerges, like the planet itself refusing to reveal its final secret. The more we learn, the more questions multiply. Why do the shadows appear in regions that lack frost? Why do they sometimes pulse in rhythm, as if following a hidden frequency? And why do they behave differently from year to year, as though Mars itself were experimenting with its own climate? Even the best simulations and AI analyses only deepen the mystery. We can reproduce parts of the phenomenon on Earth, but never the whole. There is always an element missing, something that only exists under Martian skies. It's as if the red planet has a private relationship with sunlight, one we can only watch from afar. Some scientists believe the mystery endures because of perspective. We're trying to interpret alien behavior through human logic, forcing Earth's rules onto a world that plays by different laws. Perhaps these shadows are not strange at all, but normal expressions of a planet that never belonged to us. Others suspect that the unknown factor may lie beneath the surface, something we can't yet see or measure. Subterranean gases, magnetic anomalies, or even slow tectonic movement could all contribute. The shadows, in this sense, are the planet's visible size, the skin of Mars reacting to what happens deep below. There's also the humbling possibility that some mysteries simply resist closure. The universe does not owe us answers, it only offers invitations to keep asking. And so the shadows continue to appear, dark phantoms dancing on the dunes, flickering in and out of existence. Perhaps they're just tricks of light, perhaps they're messages from a restless world, or perhaps they're reminders that even in emptiness there is movement. Even in darkness, there is life. One day, maybe a rover will catch one forming in real time. Maybe a human, standing on the red dunes, will see the shadow rise and fade with their own eyes. The shadows, then, are not failures of science, but triumphs of curiosity, proof that we still have the capacity to wonder. Every image sent back from Mars is a fragment of dialogue in a cosmic conversation. We ask with cameras, the planet replies with silence, dust, and light. Sometimes that silence speaks louder than words. It tells us that not everything must be solved to be meaningful. Some mysteries exist to keep us exploring, and in that moment they'll feel what every explorer has ever felt: awe, fear, and the weight of the unknown pressing gently against the edge of understanding. Until then, the mystery endures. The shadows of Mars remain a quiet challenge to our knowledge, and a beautiful testament to our endless desire to reach beyond the light.